Hey everybody, this is 5.1, Key Features of Parabolas. So in our last unit, we focused a lot on solving, and in this unit we're going to get into graphing those same types of equations. Alright, so just to save some time, I have a lot of this already kind of filled in. I have this on Canvas, like a filled in notes version of your notes that you can always look at, or you can follow along with this video. Okay, so key features. Well, I guess first off we talk about what does this equation look like. Okay, so when you graph a quadratic, it makes this shape. It's called the parabola. Okay, it can look like that. It can be more stretchy or wide, or it could be like flipped upside down. So all those different types of things that you've maybe talked about before with like transformations and things like that, all of those things apply, but we'll get into that as we go along. All right, so this shape is called a parabola. All right, it's kind of like a U shape, or it could be upside down, kind of a U shape. All right, and there are key features for parabolas. There's a lot of them. I have them written here, but some of them you've probably talked about before with like x and y intercepts, and maybe some other things that you haven't talked about, like maybe vertex or max. Okay, so let's talk about those one by one. First off, we have is the y-intercept. It's the point where the graph crosses the y-axis. So here would be our example of the y-intercept. Okay, and let's write that down. So really what you're going to be asked to is to identify the y-intercept by writing down its point. So for this example, if we look at that, it was at 0, 8. So we would write that down, 0, 8. All right. Please make sure that you realize when you write a point, it's always our x first and then our y value, and use parentheses. All right, next we have is the x-intercepts. Those are where it crosses, that parabola crosses that x-axis. And for this example, we have 2. One note is that we can also have one x-intercept, and that's like this middle example, where it just touches at one point, and we'll talk about that special point in just a little bit. And then we could also have no x-intercepts, and that's where it doesn't cross the x-axis at all. One thing that you can be aware of, since last unit we talked about solving, this is where we get real and imaginary solutions. So we get 2 real solutions if it crosses the x-axis twice. We get 1 real solution if it touches one time at that, what's called the vertex. If you were to solve that equation, you would have 2 solutions, but they would be the same. And then we also have imaginary solutions when we have no x-intercepts. So that's something that you could note down, and it's kind of something you could remember, okay? All right, so we've got our y-intercept, x-intercepts. Let's write those down. So it looks like we have one at -2, 0. So -2, 0, and we have one at 4, 0. Okay, again, please write it as an ordered pair. All right, next off is called the axis of symmetry. It's this vertical dotted line. It's the line that if you were to fold that parabola over that line, it would line up with the other side perfectly. It's symmetric. Okay. All right, and how we write that, I think I actually erased it, that it was up here. So this is our, this vertical line is our axis of symmetry. Okay, and it is a line, so we can't just write down like 1, okay? It's x equals 1. A vertical line is x equals. And then where it crosses that x-axis is at 1. So x equals 1. All right, so that's the axis of symmetry. Next is our vertex. It's this green point. It's the turning point of the parabola. So it looks like it's increasing up until you get to the vertex, and then it starts going back down. That turning point, or that inflection point, is where is the vertex. Okay, and that's one of the most important. Okay, let's write that one down. It looks like it's at 1, 9. So we'll write that over here. 1, 9. Yes, it's probably the most important key features. We're going to be spending a lot of time on identifying that, finding it from like an equation. Okay. Next is the max/min value. So this is the yellow. So it's for this example, we have a maximum. It's the highest value of this parabola. There's not a minimum. These arrows at the bottom, they just keep going forever and ever. They never reach a minimum value. They go to negative infinity, okay, which isn't a value, so we can't say it's a minimum, okay? So here we have a maximum. It has a maximum at 9, so that's its highest value. So let's write that down. So we have a max at 9. And then the last thing is called the direction of opening. Okay, the direction of opening, it's opening down if it's like a frowny face. So this would be a great example of opening down. I guess we'll just write down. And then if it was opening up, like these examples that we had here, those are all opening up. Okay, so let's write that down. So this example is down. Okay, so those are like the basic key features of a quadratic, or if we looked at its graph, it's a parabola. If you have any questions, please let me know. Again, if you need to like pause and write these down, you're welcome to do so, or you can go to the PDF on Canvas. All right, so there are some other key features. Well, I guess maybe we could do an example real quick. Maybe that would be good. Okay, so let's look at this example. Write down our x-intercepts. Again, that's where it crosses the x-axis. So we would have one at -2, 0 and 6, 0. The y-intercept is where it crosses the y-axis. So that would be 0, -6. Axis of symmetry is that vertical line that cuts the parabola in half. So this one would be x equals 2. The vertex is the turning point, so that is 2, -8. And we have a minimum value of -8, and it opens up. Okay? For example 3, we're just going to talk about A. So x-intercepts, what are the x-intercepts for example 3? And hopefully you'd say, Mr. Warner, there aren't any. And that would be correct. We could say none, okay, or NA. There are no x-intercepts. And again, if we had solutions, these would be imaginary solutions if we were to graph or solve this equation. Okay. All right, next thing we're talking about are intervals. Intervals are just like where these things start and end. There's two different ways we can write them. One is called interval notation, and the other is called inequality notation. So we're going to spend the most time talking about interval notation, but we'll probably just give you an example here for inequalities just in case. All right, so first off, we're going to look at example 3 to answer these questions. All right, that's why I put a little arrow over to it. First is domain and range. So domain is all possible x values. We just scan left to right. So where does it start being x, and when does it end going to x? Okay, so for this one, this graph, I mean, for all quadratics, they go forever in the left and right directions. Okay, so we would say it starts at -infinity. So So way, 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 way infinite that way. And this parabola also goes infinitely to the right. Okay, so it would go from negative infinity to infinity. And again, that will be for all cases for this unit. Okay. Range is how low and how high this parabola goes. So how low does this go? Well, it goes all the way down to negative infinity. And we need to know how high it goes. Well, it goes up to its maximum of -1. Okay? Here we're going to use a bracket. So let's talk about the difference between parentheses and brackets. So parentheses do not include the value, and here it includes the value. So when we talk about range, range goes from negative infinity, which isn't a number, it's not a value, so we can't put a bracket on it, but the y value goes all the way up to -1, and it includes -1. Okay, so it has a y value at -1. So we need to use a bracket there. All right, next is increasing and decreasing. All right, let me just clear this out just a little bit. So increasing is where, maybe I'll use green here. Increasing is where we have positive slope. Okay, where the x, it's an x interval where y is increasing. So it's like if you're going for a hike, here we're getting higher and higher. Sorry, I'm looking over here. We're hiking and hiking until we get to this maximum. Okay, after that, you're hiking and you're decreasing your altitude. Okay, so increasing for this example would start at negative infinity and go all the way to -4. So it would go from negative infinity all the way to -4. Okay, and we wouldn't use a bracket. Why? Because when you're at that vertex, you are not increasing or decreasing in that point. The slope would be 0, and then at that, right after that, it would start decreasing. Okay, so if we have positive slope here on the right, on the left side, and we have negative slope on the right side, then there's got to be a point in the center where it's not increasing or decreasing. It has to have a point where it switches. Okay, and that would be the vertex. Okay. All right, then decreasing, maybe I'll change that to red. That would be all of this. This is all decreasing slope. So it would start at -4 and go all the way to infinity. So -4 to infinity. And again, we don't use brackets because we don't include that value, the same reason why. All right, so domain is how far to the left and to the right, goes forever for the domain. Range is how low and how high, okay? And then increasing is where we have positive slope. So that was everything this side of the axis of symmetry. And then decreasing was right of that axis of symmetry. All right, next we need to maybe just touch really quickly on inequality notation. So inequality notation is things like less than or equal to, greater than or equal to. So we can also write down these intervals using inequality notation. So for like a domain, it would start at -infinity to infinity, and x would be in between those two. So it's all x values that are between -infinity to infinity, and that's everything, right? All right. Next we have range. Again, that's how low and how high, but when we do inequality, it would be all y values that are less than or equal to -1. And then it's kind of the same thing for increasing and decreasing. This would be all x values that are less than -4, and this would be all x values greater than -4. So just some examples of those in case you need it. The majority on your homework and your test, I would focus more on the inequality notation, sorry, say that again, interval notation, but be aware of inequality notation, okay? If you were to see something like this, what does that mean? Okay, or something like this, what does that mean, okay? All right, so let's do a couple examples real quick and see what you think. Feel free to pause if you want. So domain, again, is how far to the left and how far to the right. So this goes from -infinity all the way to infinity. Again, that's the same for all of these examples. Range is how low and how high. So range starts at would be at -infinity all the way up to its maximum. So it would go from -infinity all the way to 4, and we use a bracket. Oh yeah, so maybe I should mention this really quick. Range is like the special child, okay? It's the only one that uses the y-axis. So the numbers on the y-axis, like here we used 4, -infinity to 4. Okay, everything else uses the x-axis, and I have a note on that over here. So increasing, decreasing, domain, all uses the x-axis. Range is also the only one that we will use that uses a bracket. So just keep that in mind. It's your special child, okay, that gets all the special things. All right, so next off we have, maybe we'll do the range for the example 5. So how low to how high? How low would be -2 all the way up to infinity. So it starts at -2 and goes forever. All right. Okay, increasing, decreasing. Let me just erase that really quick. So increasing is where we have positive slope. Okay, I don't know if you can see that very well. So this is all positive slope, and it goes from -infinity to -1. So -infinity to 1. And then decreasing would be this side of your graph. So it would go from -1 to infinity. Oops, I missed a negative there, didn't I? Right here. Okay. All right, pause and give this a try if you would. So positive is this side, this half of the axis of symmetry. So it would go from 4 to infinity. And then decreasing, this is all negative slope. Again, if you're going for a hike, we're going lower and lower. So it would go from -infinity all the way to 4. Okay. If you have questions on that, let me know. I'd love to talk about it, and if it's not making sense, we can always talk about it maybe a little different that might make more sense to you. All right, the last 3 is positive, negative, and end behavior. Okay? So positive and negative basically is positive y values and negative y values. Okay? So positive y values are x is an x interval where the parabola has positive y values. So positive y values would be these. Okay, I'm going to try and highlight that a little bit for you to see. Okay, those are all positive y values, but again we use the x-axis to write down our interval. So this would go from -3 to 1. Okay, and then negative y values would be all of this and all of this. So it would go from -infinity all the way to -3. So -infinity to -3. And then we would also do the other side. So this would go from 1 to infinity. So So this has two parts for this. And then we'll do a union, that stands for union. Okay, and we'll talk more about that when we do probability. Okay, we union or bring them together to make one set. Okay. Oops, looks like my pencil's almost dead. Okay, so let's try this one together. All right, or you can pause it if you'd like. Positive intervals would be this part. Negative y values would be between 2 and 6. So negative goes from 2 to 6, and then positive starts at negative infinity to 2, and we union that to 6 to infinity. Oops. All right, okay, again, negative is just negative y values, so it's everything that's below the x-axis, and then positive y values is everything above the x-axis. But we use the x-axis to do the interval. All right, last but not least is end behavior. So basically it's saying, where are these arrows going? Okay, I'm going to kind of erase this really quick so it's not so messy. Okay, as you follow the graph to the left or to the right, where do the arrows go? Do they go up or do they go down? Okay, so that's basically what we're doing, but when we say left, when you think about left, that's going to negative infinity. And if you're going to the right, in the x direction, it's going to positive infinity. We want to know, where are the arrows going for the y's? Are the y's going down to negative infinity, or are they going up to positive infinity? So for this example, both of those are going to negative infinity for the y's. Okay, so I kind of have that written down there. The black part will never change. You're always going to check to the right, so that's positive infinity for the x, or we're going to check the left side, and that's negative infinity. Okay, and then we just need to say, where are the y's? For the arrows, for the y's, are they going down to negative infinity like this, or they're both going up to positive infinity? And that's what we have here for C. Okay? All right, so again, what we're saying here is we just want to check to the right. Again, that's positive infinity. If we go to the right, it goes to positive infinity. Where is the arrows going for the y values? Well, they're going up. So x is going to infinity, and y is going to positive infinity. So that's up. And then for the left, y is also going up. Okay. All right. Well, if you have any questions on those, let me know. Again, especially these last three, I think some people kind of struggle with those, and that's all right. Just come and talk to me, and we'll figure it out. All right, and then here for 16, I would recommend maybe pausing and filling this in without looking, and check your work. All right, if you have any questions, again, just let me know. We'll see you later.